Hello, everyone, and welcome to a new lecture on the truth values of the logical statements. Last time we did the truth value of the negation, the disjunction and conjunction, and now it's time to talk about the remaining two operators, which are the conditional and the biconditional. So before I go that, remember, so for the negation, we said this one here. So if you have a statement P, that statement P can be either true or false. So the negation of P will be false, true. So if P is true, then negation of that is false. If P is false, then the negation of false is true. Now, this is the negation. This is the basic truth table of the negation. And those basic truth tables are not negotiable. You have to memorize them. You have to know them really by heart, because you will use them to construct truth tables of more complicated statements, or sometimes called compound statements. How about the end, the conjunction? All these words, they mean the same thing, conjunction. So if you have two statements, P and Q, here's one, this is P, and this is Q, right? Either both of them are true. The first one is true, the other one is false. The first one is false, the other one is true, or both of them are false. So, and then we are going to have what's called the truth table of this conjunction. And this is P and Q, or Q and P. And we have seen when both of them are true, P and Q is true. If one of them is false, then it will be false. And of course, if both of them are false, then the whole thing is false. This is the truth value of the conjunction. And the last one we did last time is the truth value of the disjunction, the or, right? This is the or statement, sometimes called the disjunction. If you have two statements, P and Q, of course, you can call them anything you want. You can call them R and S or P and S or whatever. So this is P or Q. So either both of them are true, or one of them is true, the other one false. The first one is false, the other one is true, all false, false. So either they are both of them true, true, false, false, true, or false, false. So when you have the or, the or is false when both of them are false, otherwise is going to be true. So we did again the negation, the conjunction, and what? The disjunction. This time we'll be focusing on the conditional and the biconditional. So this lecture is about working with the conditional I and by the biconditional. So this is called sometimes conditional, sometimes called the if-then statement, and this one called the if and only if. Remember, we use IFF to shorten the if and only if statement. All right, let's get to do this. Well, sorry, well, I said, let me erase this one here because it's, so I'm writing on a slide that will pop up, so it will be less confusing for all of us. I should have created an empty slide, and it's a little bit too late now. Okay, so we're going to learn how to construct a truth table involving conditional statements. We're going to learn how to construct truth tables involving biconditional statements. And we are going to define what's called tautologies, self-contradictions, and implications. But the most important thing is the first 2 points. Okay, well, here is the truth table of the conditional. So if you have a conditional, you have two statements, P and Q. Either both of them are true, right, which is the case 1. The first one is true, the second one is false, which is case 2. Case 3 is when P is false and Q is true. And the last case is when both of them are false. So if you have true conditional, true is true. If you have false conditions, true is true. And if you have false condition, false is true. The only situation where the condition is false when the antecedent, I don't know how to say this word, antecedent is true and the consequent is false. So when this one is true and this one is false, then the conditional is false. Otherwise, it will be true. So this is now the truth table of the conditional. So add this truth table to the truth tables of the negation and the conditional and the conjunction and disjunction. And those, again, I said this, I don't know how many times now, but those basic truth tables are non-negotiable. You really need to know. If I tell you true, if true, then false, is it false or true? Then you should say false. If false, then true, then true. If false, then false, that's true. All right, so you need to memorize this. Now, how are we going? Well, here's an example. Before I do the other one, here's an example. How are we going to construct the truth table of the negation of P implies negation of Q? How do you read this? If you say if not P, then not Q. Yeah, that's how you read this one. Well, look, I'm going to have two columns, one for P and one for Q. Then I'm going to construct the negation of P, then construct the negation of Q, and at the end, I'll do the conditional. So watch. So here is my P, here's my Q, here's my first case, the second case, the third case, and the fourth case. Now I'm going to do this. I'm going to do the negation of P as a first step, negation of Q as a second step, and the third step is do the conditional between these two statements, which are the negation of P and negation of Q. So step one, just fill in the negation of P column. So how do you do that again? Well, just do the negation of P. So when P is true, then the negation of P is false. And when P is false, the negation of P is true. Then I'm going to do this column here and just flip the truth values of Q. Okay, now, if you have false, arrow false, what's the whole thing? The whole thing is true. If you have false, arrow true, it's true. If you have true, arrow false, that's false. If you have true, arrow true, that's true. So how did I do this column? Well, I did this column using my basic truth table. It tells me true, arrow true is true, true, arrow false is false, false, arrow true is true, and false, arrow false is true. That's how I did that. So I did step one and step two. Now it's time to do step three. Yeah, and just like I showed you before. Okay, this is how it goes. Okay, now let's do the truth table of the biconditional. Well, there are two ways to look at it, but I'll show you the easy way. The easy way is to give you that table and ask you to memorize it, because those are basic truth tables. So here's the P, and here's the Q, and here's the P if and only if the Q. I think I'm going to show you just this one here. This is an easy one. The remaining slides are going to be confusing. I think we can skip that without any harm. So here's my first case. If they are both true, the last case when they are both false, the second case when the first one is true, the other one is false, and I reverse them, false, true. So the truth table of the biconditional, if both of them are true, the whole thing is true. If both of them are false, the whole thing is true. Otherwise, it will be false. It's easy. Right? So take a moment and recognize this table. So the biconditional of two statements is true if both the statements are either true or both of them false. Otherwise, it will be false. That's it. That's what it is. So I'll go faster on the remaining steps. Well, this is what I did. So when both P and Q is true, it is true, right? And when both of them is false, it is true. If the remaining case, it is false, right? So how did I do this? Well, I recommend that you don't pay attention to this. It just, let's go back and focus on this one here only. That's all you need. That's it. If it bothers you a little bit, you can always email me or can go to the textbook and read more about it. It kind of like makes sense. It says if and only if. If and only if means what? Both of them must be of the same truth value for the whole thing to be true. Yeah, if they are different, it's false. So as you can see, the biconditional statement P if and only if Q is true only when P and Q have the same truth value. That is, both of them are true or both of them are false. That's exactly what I said. Okay, now how are we going to construct this? This is a statement that has biconditional, conditional, and so forth. Well, how many statements do we have here? We have P and Q and R. And this is the first time we are doing a truth table when we have 3 statements. When we had 2 statements, P and Q only, we had 4 possibilities or 4 cases when both of them are true or both of them are false, when the first one is true, the other one is false, or the last case when the first one is false, the other one is true. But when you have 3 statements, P and Q and R, it's going to be a little more complicated because they can be all of them true, the 3 of them true, the 3 of them false, true, false, 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 true, 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 false, false, true, false. And you see what I'm trying to say here. You really, when you are asked to do the truth table of the whole statement, and the statement is contained 3 statements, simple statement P, Q, and R, then we are going to have 8 possibilities. Well, how can I tell? When I had P and Q only, I had 4 cases. Well, how do you obtain 4? Is 2 to the power 2. Now, if I have P, Q, and R, I'm going to have 8 cases. How I obtain 8 is 2 to the power 3. Now, what happens if I have P, Q, let's say R and S? Then I'm going to have what? 2 to the power 4, which is 16 cases. It's going to be a huge table. So the table I'm going to have here of the whole thing, the table of the whole thing, will contain 8 rows, 8 cases. Watch. Okay, here are the 8 cases. So first one, second, third, fourth, fifth, sixth, seventh, and eighth. Okay, this is one way to look at it, how to fill in the values T's and F's. Have you noticed that we have 4 T's, 4 F's? Just gives you a quick way to fill in. And then I have 2 T's, 2 F's, 2 T's, 2 F's. Then 1 T, 1 F, 1 T, 1 F, 1 T, 1 F, 1 T, 1 F. If you do it this way, it is guaranteed that you are not going to miss anything. So let's do this one more time. So if you have 3 statements, P and Q and R, you are going to have a table of 8 rows. In the first column, put 4 T's and then 4 F's. You just whatever number you have here, divide by 2, and you get 4 T's and 4 F's. And what happens if I have 4 statements? I'm going to have 16 rows, right? So and divide 16 by 2, the first column will be 8 T's and 8 F's. And the column next to it will be 4 T's, 4 F's, 4 T's, 4 F's, and so on. But let's not worry about the case when we have 4 statements because it's too long. Nobody would ask you that. Yeah. So let's go back to this example. Again, I have 3 statements, P, Q, and R. Means I'm going to have 8 rows, right? Or 8 cases. So how come I'm going to fill the T's and the F's? In the first column for P, I'm going to have 4 T's and 4 F's. The next column, I'm going to put 2 T's, 2 F's, 2 T's, 2 F's. And the last one for R, I'm going to put TF, TF, 1, 1, TF, TF. By doing this method, it is guaranteed I'm not going to miss any case. I have the case when all of them true. I have the case when all of them false. I have any case that comes to your mind. For example, if you ask me, what is the case? Where is the case when the first one, P, is true and the remaining one is false? I'm going to here it is. If you try to do this in a random way, there is a chance that you're going to miss one of the cases, and there is a chance that you are going to duplicate the same case again. So keep that in mind. So that's why we go on to this one here. Once you set up your table like this, the remaining is so easy. So it's time to do the negation of P. Well, how can you do the negation of P? Just flip those. If it is T, make it F. If it is F, make it T. Or I can do the negation of Q. So it doesn't matter which one. So this is the negation of Q. Just flip the Q. And then R stays the same. So R stays the same because I did R. Now I'm going to do the negation of P. Well, like between the parentheses, there are choices, of course, but the final answer is here. The final step will be here. So you can do this first, then this one, or I can do this one here, then this one, then this one. It doesn't matter. Well, once you have these 2 set up, now it's time to do this one here. So false conditional, true is true. False conditional, false is going to be true. True conditional, true is true. True conditional, false is false. This is, watch out, this is false. False conditional, true is true. False conditional, false is true. True conditional, true is true. And true conditional, false is false. So the only places we have false is there. So this is what's going to happen. 3TTTF. Now that I have this, it's time to do the negation of P. Just flip the truth values of P. Now I am going to, my last step, it's going to be between this, the biconditional of this and this one here. So false biconditional, true is false. False biconditional, true is still false. False biconditional, true is false. False biconditional, true is true. True biconditional, true is true. This is true, this is true, and this is false. And watch, let's confirm this. False, 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 true, 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 false. And this is your result right here. They're going to put a rectangle around this one here. So what does this mean again? It means, let's say, for example, if you ask me to read this, when P is false, Q is true, and R is false, that statement they gave me is true. Well, I think we can stop. There's no really need to do this example. The homework, there are similar examples for that. So I'll stop here for this lecture. So what we just did, we covered the conditional of the, the truth table of the conditional and the biconditional. And then that's how it goes. You need to know the basic truth tables of those conditional biconditional. Now, if it happens that the final result is all true, it's called a tautology. If it happens that the final result is all false, it's called a self-contradiction or just a contradiction. Otherwise, it's just a statement. Tautologies and condition and contradictions will be covered more in details in the next lecture. Okay, so as of now, ask yourself, can you do the basic truth table of the negation? Can you do the basic truth table of the conjunction? Can you do the basic truth table of the disjunction? Can you do the basic truth table of the conditional? And the last one, can you do the basic truth table of the biconditional? If you can memorize all these 5 truth tables, then you can construct the truth table of any compound statement. I think you are ready now to go and do the homework of this section, and good luck.